Okay, so today we're going to be going over 2.3, using deductive reasoning to verify conjunctures. So the objective is to apply the law of detachment and the law of syllogism in logical reasoning. And the vocab is deductive reasoning. So deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. So in 2.1 and 2.2, we were using inductive reasoning, and now we're going to be using deductive reasoning, which deductive reasoning uses logic to draw conclusions. So here's an example. Is the conclusion a result of inductive or deductive reasoning? There's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, this myth is false. So would this be inductive reasoning or deductive reasoning? It would be inductive because the conclusion is based on a pattern of observation. So it's giving us facts that the person was able to balance the egg on their head on these dates. So it's using observation to come up with their conclusion. So this is inductive. Remember, deductive is using logic to come up with the conclusion. But this is using a direct observation. So this is inductive. Is the conclusion a result of inductive or deductive reasoning? There is a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above Earth. The moon is about 237,000 miles from Earth. Therefore, the myth cannot be true. So would this be inductive reasoning or deductive reasoning? This would be deductive reasoning because you're using logic to come up with the conclusion. So it's saying that the Great Wall is barely visible from Earth in the photos that have been taken, and the moon is super far from Earth. Therefore, the myth can't be true. So they're using logic. So they're using what's given and using logic to come up with their conclusion. So this would be deductive. One more example. There's a myth that an elk skin wallet will demagnetize credit cards because the skin of the electric eels used to make the wallet holds an electric charge. However, elk skin products are not made from electric eels. Therefore, the myth cannot be true. Is this conclusion a result of inductive or deductive reasoning? Deductive, because it's based on logical reasoning. So this is deductive. In deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. So the law of detachment states that if P then Q is true and P is true, then Q is true. So we have if P then Q is a true statement, and 2, if P is true, therefore Q must be true. So this is the law of detachment. So the statement, if the battery of a car is dead, then the car will not start, is a conditional statement. So what would be our hypothesis of this statement? If the battery of the car is dead, so that's our P, then what's our conclusion? Then the car will not start, so that's our Q. So this statement is given to us in the form P, then Q. So if P then Q is a true statement and P is a true statement, then Q would be a true statement. So we need two things to happen. We need one, P then Q to be true, and two, P to be true. So let's see if these are true. P then Q is a true statement since we all know that if the battery of a car is dead, the car will not start. So P then Q is true. Check. Is P true? The mechanic checked out your car and found that the battery is dead. So P is true. So we know that if the car battery is dead, then the car will not start. That's true. P is true. The car battery is dead. Therefore, we can imply that the car will not start. So our conclusion is that Q is true. The car will not start. And this is because the law of detachment. So it's important to make sure that the conditional is true. So the conditional meaning the whole P, then Q, before using the law of detachment. Otherwise, you could end up making the wrong conclusion. So we need P, then Q to be true. Remember, we need two things to be true. So P, then Q has to be true. This is one. What's the second thing we need to be true? P has to be true. And then we can conclude that Q is true. So let's look at some examples. Determine if the conjuncture is valid by the law of detachment. In the World Series, if a team wins 4 games, then the team wins the series. The Red Sox won 4 games in the 2004 World Series. So is the conjuncture true? The Red Sox won the 2004 World Series. So what would be our P? If the team wins 4 games, this is our P. So what's our Q? Then the team wins the series. That's our Q. So we have if P, then Q. This is true. If the team wins 4 games, then they win the series. Now it says the Red Sox won 4 games. So therefore the P is true since the Red Sox won 4 games. So what can we imply? That Q is true. That the Red Sox won the 2004 World Series. So would this be a valid statement? Yes. So this is valid. That's all you would need to write. Valid. Let's look at another example. Determine if the conjuncture is valid by the law of detachment. If a student passes his classes, the student is eligible to play sports. Raymond passed his classes. So we're assuming that Raymond is eligible to play sports. What is our P? If a student passes his classes, what's our Q? The student is eligible to play sports. So this is P then Q. That's true. Raymond passed his classes. Is that proving which one's true, P or Q? P. Because if a student passes his classes, Raymond passed his classes, so therefore P is true. So would Raymond be eligible to play sports? Is that a valid statement? Yes. So therefore this conjuncture is valid. So examples of the law of detachment in geometry and algebra. If a figure is a triangle, then the sum of its angles is equal to 180 degrees. Figure ABC is a triangle. So what is our P in this statement? If a figure is a triangle, what's our Q? Then the sum of its angles is equal to 180 degrees. Figure ABC is a triangle. So does this go along with P or Q? Is this proving P to be true or proving Q to be true? P. So this is stating that P is true. So then what can we imply? What would our conjecture be from this statement? So if P, then Q is true. P is true. So therefore, what do we know? That Q is true. So how do we state that Q is true? So if figure ABC is a triangle, then what do we know about figure ABC? Yes. So then ABC that's right, the sum of ABC is equal to 180 degrees. If n is an even number, then it's divisible by 2. What's our P? If n is an even number. What's our Q? Then it's divisible by 2. So if 4,834 is an even number, so this is proving P to be true, then what can we assume about Q? That it's true. So if 4,834 is an even number, then what can we imply about it? So then 4,834 is divisible by 2. Another example. If the sum of two angles is equal to 90 degrees, then the angles are complementary. What's our P? Alexis.
If the sum of two angles is equal to 90 degrees.
If the sum of two angles is equal to 90 degrees, what would our Q be?
Then the angles are complementary.
And the angles are complementary. So angle X is equal to 30 degrees and angle Y is equal to 60 degrees. So the sum of these two angles is equal to 90, so that agrees with our P. This proves our P to be true. So then our Q would be true. So what can we conclude about angle X? So angle X and angle Y are complementary. If x and y are odd numbers, then x plus y is an even number. 5 and 7 are odd numbers. So what would our P be? If x and y are odd numbers, what's our Q? Then x plus y is an even number. So 5 and 7 are odd numbers, so therefore P is true. So if we have P, then Q is true, and P is true, therefore Q is true. So what can we conclude from this about 5 and 7?
The sum of x and y is an even number.
So the sum of x and y is an even number. So the sum of 5, so 5 plus 7, is an even number. Okay, so all of this was the law of detachment. Now we're going to look at the law of syllogism. So another valid form of deductive reasoning is the law of syllogism. It allows you to draw conclusions from two conditional statements when the conclusion of one is the hypothesis of the other. So now we have, if P then Q and Q then R are true statements, then P then R is a true statement. So we have, if P then Q is true, and Q then R is true. So the conclusion of one and the hypothesis of the other are the same. Then we can conclude that P then R is also true. Okay, now let's look at an example. Determine if the conjuncture is valid by the law of syllogism. So if a figure is a kite, then it is a quadrilateral. So if we're just looking at the first sentence, what would our P be? If a figure is a kite, what's our Q? Then it is a quadrilateral. So this is our Q, this one's our P. So if the figure is a quadrilateral, look, this is the same statement as the sentence before. So this would also be our Q. Then it is a polygon. So this is a new statement. So this would be R. So if P then Q is true, and Q then R is true, so we have if P then Q is true, and Q then R, the conclusion of one and the hypothesis of the other are the same. The two middle ones are the same. So therefore, we can conclude that P then R is true. So if a figure is a kite, this is P. Then it is a polygon, this is R. So notice how the red ones are the same. So I'm saying that this is P because this one is P. If a figure is a kite, if a figure is a kite, this one's R, then it is a polygon, then it is a polygon. I made them color coordinated so you can tell. So if we have P then Q and Q then R, then P then R is true. So this is P, we have P, then R. So would this be a valid statement? Yes. So this is valid. So if the conclusion of one and the hypothesis of the other are the same, then you can imply that P then R is also true. So this is valid. Determine if the conjuncture is valid by the law of syllogism. If a number is divisible by 2, then it is even. If a number is even, then it is an integer. So what would our P be? What's our P? What's our hypothesis of the first statement? If a number is divisible by 2. So this is our P. Then it is even. This is our Q. So if a number is even, what would that be? The next thing, if a number is even. Q. So if a number is even, that's our Q. Then it is an integer. What would then it is an integer be? Have we seen that phrase before? No, it's a new one. So this would be our R. Yes. So if we have if P then Q is true, and Q then R, P then Q, and Q then R, the two middle ones are the same. So we know that P then R is true. Let's look at the conjuncture. If a number is an integer, would that be P, Q, or R? R. Then it is divisible by 2. Is that P, Q, or R? P. So we have R, then P. We know that P then R is true, but we don't know anything about R then P, so therefore this would be invalid. You can't flip them around. So if we have if P then Q and Q then R, we know that P then R is true. But this is saying R then P. This is the reverse. So therefore it's invalid. So now we have if an animal is a mammal. Would this be our P, Q, or R? If an animal is a mammal, then it has hair. If an animal is a mammal, what's that? P. Then it has hair. Q. If an animal is a dog, what's that one? R. We haven't seen that one before. Then it is a mammal. We've seen that one though. Is that our P, Q, or R? P. If an animal is a dog, what's that one? R. then it has hair. Q.
Could you please set my capital sign down to the third sentence?
Yes. So we have if P, then Q, and if R, then P. I'm just looking at the given. Are the two middle ones the same?
Yeah. No.
No, but we could move this over here. And erase this one. Now are the two middle ones the same? So we have the conclusion of one is the same as the hypothesis of the other. So therefore we can imply that if R, then Q. What is this one saying? If an animal is a dog, that was our R. Then it has hair, that's our Q. So is this conjuncture valid? Yes. So we just rearranged the given. We made the first sentence our second and the second sentence our first. So therefore, the conclusion of one is the same as the hypothesis of the other. So this would be valid. If the sum of the measure of two angles is 180, then the angles are supplementary. So let's look at the first sentence. What's our P?
If the sum of the measures of two angles is 180.
The sum of the measures of two angles is 180. What's our Q? And the angles are supplementary. If two angles are supplementary, then they are not angles of a triangle. So if two angles are supplementary, we've seen that before. Would that be P, Q, or R? That's Q. So that one's red again. They are not angles of a triangle. Have we seen that one before? No, so this would be our R. So we have P, then Q from the first sentence, and Q, then R from the second. The two middle terms are the same. So what can we imply about P, Q, and R? That P, then R is true. So we're taking the P, and we're taking the R. We're just dropping the middle terms. So if the measure of angle A is 135 degrees and the measure of angle B is 45, what is this proving? Does it go with the sum of the measures of the two angles is 180, the sum of the angles are supplementary, or they are not angles of a triangle? Do they add up to 180? Yeah, so this goes along with the P. So if the P is true, the sum of the measures of the two angles is 180, then R is true. So therefore, they are not angles of a triangle. So angle A, and angle B are not angles of a triangle. Okay, let's look at another example. If a polygon is a triangle, then it has 3 sides. So what's our P? The polygon is a triangle. What's our Q? Then it has 3 sides. So we have P, then Q. Let's look at the next sentence. If a polygon has 3 sides, we've seen this before. So this one would be our Q. So now we have Q, then it is not a quadrilateral. Have we seen that one before? No. So this would be our R. So now it says polygon P is a triangle. So this goes along with our P. So if we have the 2 middle ones are the same, then we can imply that P then R. So if polygon P is a triangle, then it is not a quadrilateral. So polygon P is a triangle, goes along with this. So then polygon P is not a quadrilateral. Okay, this will be our last example. There's 2 more after this, but I'll put them in the video. So if you guys want to see more examples, just watch the video. Is the conclusion a result of inductive or deductive reasoning? At Reagan High School, the students must pass geometry before they take Algebra 2. Emily is in Algebra 2, so she must have passed geometry. Is this an example of inductive or deductive reasoning? Deductive. Because we're applying logic to assume that she must have passed geometry. So this is deductive. Okay, we have time for one more. If n is a natural number, then n is an integer. If n is an integer, then n is a rational number. So we have, let's look at the first sentence. If n is a natural number, this would be our P. Then n is an integer. This is our Q. If n is an integer, we've seen that one before. That's our Q also. Then it is a rational number. So that's our R. So we have if P, then Q, and if Q, then R. So what do we know about Q then R? About P and R.
That is true.
So therefore P and R is true. So if 0.875 is a rational number, so this is talking about rational numbers, so this goes along with R. Can we assume that it is a natural number? Can we assume that P is true if R is true? No, because we can't flip them. Because it's only P then R, we can't say R then P. So determine if the conjuncture is valid. Given if an American citizen is at least 18 years old, then he or she is eligible to vote. Anna's a 20-year-old American citizen. So in this one, we will use the Law of Detachment. So if an American citizen is at least 18 years old, this would be our P. Then he or she is eligible to vote. That's our Q. So we have if P, then Q. Anna is a 20-year-old American citizen. So this is proving that P is true. So then Q is true and P is true. So therefore, we can assume that Q is true. So therefore, Anna is eligible to vote. So this would be a valid conjuncture.